because as I said that we have attached a thermocouple at the center of the sample, but this thermocouple has been attached manually at the center of the sample, so there can be some differences due to this manual attachment of the sample. And of course, the thermocouple is always attaching a curved surface of the sample, and we cannot measure exactly the temperature at one point of the sample by using this technique. Now at this point we validated with this little error, we validated that we can use laser irradiation to actuate, to have the phase transformation in the shape of your oil, and we proceeded towards the wireless pneumatic actuation principle. For this principle we have used two infrared diode laser sources, each having 65 milliwatt laser power, and two red diode laser sources, each having 85 milliwatt of power. Two SMA samples have been selected, each having size 4 mm by 4 mm at 100 micrometer thickness, and two spectral filters have been selected. I will just explain this earlier. These two spectral filters have been constructed by a substrate, and the thin films have been deposited on this glass substrate of hydrogenated amorphous silicon and plasma polymerized methacrylic acid. And the thicknesses of each thin film have been given in this table. Now the property of this spectral filter, the T1 can transmit 90% of 785 nanometer wavelength, but only 21% of 658 nanometer wavelength, and T2 can transmit 89% of 658 nanometer wavelength, but it can only transmit 12% of 785 nanometers. So the sample covering with TL2 should respond with red laser, and the sample covering with TL1 should respond with infrared laser. I will just explain this in detail, this principle. First of all, the two samples have been deformed at the room temperature, and with the red laser sources on, we can have a change in SMA2, which is covering with GL2. Again, we have deformed these samples, and with red laser sources on, we can have a deformation in SMA1. And if we on the two laser at the same time, the two samples will regain their original positions. This experimental work as it has been carried out. The spectral filter TL1 and TL2, here it is SMA1 a bit dark. And this is SMA1 and SMA2, and these have been deformed at the room temperature manually. The SMA1, which is now red laser is on, and this is the SMA1 has been deformed at room temperature. But as it has been covered by TL1, which cannot transmit red laser, so there will be no change due to this red laser. Infrared laser has been on, and we will change the phase transformation in SMA1, and we will regain its initial form. So it was no process because we have chosen a little bit more, bigger less laser power, that is about 65 milliwatts. We can see the same procedure for SMA2. Here, infrared diode sources has on, which cannot be visible here. Infrared diode source. And due to this laser irradiation, this will not transform its shape. After some time, we have switched off the infrared diode source, and the red diode sources have been on. You can see the reflection in the SMA. And this reflection can be used to actuate the system. The basic purpose of this study was to deposit the thin film directly on the nitinol sample, and we have done this also, and with this video you can see. Here the films have been directly deposited on the nitinol sample, and it has irradiated by red lenses, but we will not see any change because these thin films only transmit infrared laser sources. And with infrared laser sources on, we can see a change in the shape of the SMA. Here the sample has been covered with the thin films which can transmit red lasers but not infrared lasers. So with infrared laser sources, there will be no change in the basic shape of the sample. And the direct laser sources will regain its initial form. I conclude. I discussed the numerical modeling and simulation of a proposed system by event of phase transformation has been done by using miniature thermocouple, and a good agreement was found between experimental and numerical results. And then the feasibility proof of wireless chromatic actuation principle has been discussed. The perspective of this work is to develop a more comprehensive bistable microactuator, complete bistable microactuator, and some improvement in numerical modeling have been in consideration, and the optimization of the evolution of the thin layers directly on ethanol will be done in future.